So if let's say, for example, okay, if I have a compound, yeah, for example, if I have cobalt, okay, and then I am going to have ammonia, 3 molecules of ammonia, and then I'm going to have, okay, for example, Cl, okay, 3 molecules of Cl. Let's say this is going to be a complex, okay, so I'm just taking an example over here, and you can see that ammonia is going to be a monodentate ligand. Cl is also a monodentate ligand, and you can see that they form 6 coordinate bonding. Yeah, it means they are going to actually have coordinate number for CO. They have 6 coordination number. Yeah, because 6 dative bonds over there. So if let's say they ask you to draw all the isomer that exists for this compound. Yeah, for example, for this substance. Yeah, the stereoisomerism, yeah, you need to know that we have two, which is going to be cis and trans, and we also have what we call as optical isomerism. Now, for optical isomerism, yeah, so please remember, cis and trans, okay, they can exist, okay, in both, okay, if it is going to be square planar, okay, they can actually exist in square planar. They can also exist, okay, in terms of if you have the shape of octahedral. Okay, they can also exist over there. Okay, if it is octahedral also can. Okay, if you have cis and trans. Okay, we have done some examples. Yeah, but when it comes to optical isomerism, yeah, optical isomerism is more towards, okay, we are looking into octahedral. Okay, we are looking into octahedral. And at the same time, octahedral must have, okay, they must have bidentate ligand. Okay, so we actually look into that. Okay, so cis and trans, okay, they can exist in square planar and octahedral, optical isomerism, octahedral, and then it must be bidentate. Yeah, some kind of notes over there. Okay, but let's say if I want to actually look into stereoisomer for this, of course, okay, this is not going to exhibit optical isomerism, okay, because, okay, they do exhibit octahedral, okay, if you put it over here, they do exhibit octahedral shape, but they are all monodentate, yeah, they are not bidentate. Therefore, okay, they will exhibit, okay, cis and trans. Okay, this is how you determine, okay, cis and trans. So let's actually try to draw the cis and trans for this. So this is not the mirror. I'm just going to separate cis and I'm going to separate trans over here. Okay, so let's say, for example, if you're drawing something related to octahedral shape, okay, I will always ask you to draw like this cobalt. Okay, then after that you draw like this. Okay, make sure you follow this. Okay, you draw like this, and then we have this, yeah, dotted line from behind, and then this one to show is coming in front. Okay, so for this one, I'm going to select this, okay, and then copy and then put it over here. Okay, so I can actually use them again. Okay, maybe I will actually also use later also for this and also for this. Okay, I'll just keep it aside first. Now, this one is I want to actually show for cis and trans. Okay, so whenever you want to draw for cis and trans, please remember, okay, if you have like, for example, three ammonia and 3 Cl, okay, my suggestion is, okay, do not use, okay, let's say, for example, if you put ammonia over here, okay, don't go and put ammonia over here. Okay, don't go and put ammonia over here. You always put the one that is different, Cl. Okay, if you put ammonia over here, you put the Cl. Okay, this is one of the trick to get the cis and trans. Yeah. Then the next thing is, okay, you can actually choose between ammonia or Cl. Let's say, for example, I'm going to put Cl. Okay, Cl, because this one is going to be Cl, maybe I just put the Cl over here. Yeah, I put the Cl over here. Doesn't matter. Cl can also come over here. Yeah, it's still okay. Okay, but the next thing that you are going to draw is going to be very, very crucial. Yeah, so you must make sure. Yeah, you must make sure if you want to draw cis, okay, the beside. Yeah, you must make sure, okay, that okay, the atoms, okay, that is going to be side by side, okay, must be Cl. Yeah, so if I put, okay, Cl over here, okay, this is going to be side by side. Okay, side by side, and then you put the ammonia here, and you put ammonia over here. Okay, this is what we call as cis. Okay, why it's going to be side by side? You can see side by side. Okay, now if I want to actually draw the same thing, and I'm going to show trans. Okay, so just now I put the Cl over there. Yeah, so you want to show trans, the best way, if this is Cl, you put the Cl, another Cl opposite. Okay, you put another Cl opposite, left with ammonia here, ammonia here. Okay, this is how you draw, okay, cis and trans, okay, for this compound, this kind of compound. Okay, so this one just go through, yeah, just go through and so on. But now, yeah, I am going to show you, yeah, I'm also going to show you how you can actually draw optical isomerism. Okay, optical isomerism. For optical isomerism, just now I mentioned to you, okay, you can have octahedral, and we can also have, okay, situation where we can have the bidentate ligand. So now, okay, if I ask you example, yeah, of bidentate ligand, there are two examples of bidentate ligand. Dylan, can you tell me what are the two examples of bidentate ligand?
En.
Okay.
And I think the other one was C2O4.
Yeah, the C2O4 is actually OX. Yeah, so En and OX. Okay, you can memorize this. Okay, so of course it's easier to remember En and OX. Okay, but you should also know, okay, what is En. Yeah, so I'll just show you also what is OX. I will also show you. Yes, so quite easy. Okay, because earlier maybe if you want to visualize, it's going to be too difficult. But now, okay, when you want to write down, it's going to be should be easy. Why? Okay, En, okay, they will always start with CH2, CH2, ends with NH2. Okay, ends with NH2. Okay, so the ligand, yeah, the ligand is actually going to be, the lone pair is actually going to be from this nitrogen. Okay, from the nitrogen. Okay, so I will remove that first. Okay, so this is a bidentate, yeah, bidentate En, yeah, En, and then the C2O4 2 negative, yeah. So do remember this one is neutral, yeah. I'll write down this is neutral. Okay, but this one, okay, is going to be C2O4 2 minus, but I don't want you to memorize C2O4 2 minus. I want you to remember like something like methanoic acid, yeah. So this one, C double bond O, OH, supposed to be methanoic acid, looks like this. And then remember yesterday I told you ethane dioic acid, okay, this one. Okay, now imagine the acid, if it is an acid, the H plus will be gone. Yeah, so if I erase this, the H plus will be gone, the H plus will be gone. So the negative will be here, negative will be here. Therefore, that's why OX is known as ethane dioic ion. Okay, or ethane dioate, okay, TE. Okay, ethane dioate ion, okay, because it's actually related to your carboxylic acid. Okay, but relate again, okay, with what we have learned yesterday. Okay, carboxylic acid, all carboxylic acid cannot be oxidized except, okay, except is going to be methanoic acid, okay, except methanoic acid and ethane dioic acid. Okay, so these two can be oxidized, okay, can be oxidized, okay, with, okay, a strong oxidizing agent, potassium manganate or potassium dichromate acidified, okay, and they will give you carbon dioxide and water. This is going to be yesterday's lesson. Yeah. So now coming back over here, okay, this is ethane diode ion, okay, and then, okay, if let's say I want to circle, yeah, I want to actually circle the atoms that will be forming the ligand, forming the dative bond and so on. Let's say if I want to actually rewrite this in form of a proper way, yeah, so CH2, CH2, and H2. Okay, so I'll just put like this. Okay, and then you have NH2. So if they ask you to circle, okay, the one that is going to be responsible, okay, to form the dative bond, this is going to be the one responsible. Okay, but now if I ask you to circle the atom that is going to be responsible to form the ligand, the dative bond in this bi-dentate ligand over here, you circle this one. Do not circle the one that is going to have the double bond O. Yeah, do not do that. Now, if we have learned monodentate, and then I taught you about bidentate, let's actually not waste time. We just go for another one, which is going to be polydentate. Okay, since we already started with that. So maybe can you actually give me one the only example that we learned under here, Josh? Poly-dentate ligand. Can you give me the example that we have learned for poly-dentate ligand?
The hold up. Wait, give me a second, sir.
Okay, I already wrote for you, yeah? So yes, yeah, EDTA 4 minus. Okay, EDTA 4 minus. Now, why I'm actually showing you this, okay, because remember I taught you about EN just now and OX, okay? I think some of you really cannot memorize very fast. I'll show you many times, yeah? EN, okay, how EN is actually looks like. CH2, CH2, NH2, NH2. Okay, it's going to be neutral. Okay, so it's going to be neutral. En is neutral. Okay, and then for OX, okay, it's going to be C double bond O, O minus. Okay, and then C double bond O, O minus. Okay, this one we have already learned just now. Okay, now in order to draw for EDTA, EDTA is quite interesting because it looks similar to EN. Okay, if you don't trust me, I'll draw for you. Yeah, so it looks like this. It starts with C, H2, CH2. Okay, and instead of H2, yeah, hydrogen and hydrogen, they will go like this. Okay, they will go like this, and they will have CH2 over there. Okay, and they will have C double bond O, O minus, something similar to what? OX. Okay, and then CH2 here, C double bond O, O minus. Okay, do remember I'm not referring to anything. It's quite easy to memorize. Yeah, quite easy to memorize because it's related. Yeah, it's related. So you do the same thing over here. Okay, so it's CH2, C double bond O, O minus, and then CH2, C double bond O, O minus. Okay, and remember there was a past year question that they asked you to go and circle, okay, the atoms responsible, okay, for the coordinate bonding. Yeah, so if you want to circle that, of course, the nitrogen, okay, similar to what we have circled over here, nitrogen. Yeah, and then for OX, we circle over here, right? We don't circle the double bond O. The same thing, circle here. We don't circle the double bond O. So it's actually a combination, okay, of En and OX. Okay, it's actually a combination. Okay, so now polydentate is done. Okay, done. We come back. Okay, come back to our original plan over here. Okay, our original plan is, okay, I want to show, yeah, the optical isomerism. Okay, so in this case, I'm going to erase this part. Okay, so let me erase. Okay, so now I want to show optical isomerism, but now I want to do lazy work a bit. Yeah, lazy work means by using EN short form. Yeah, if they actually allow you to do that, then we use the EN short form. Okay, how to do that? Okay, the first thing, okay, always remember this: from the top to the side. EN from the top to the side. Okay, from the top to the side. Another EN from the side to the bottom. Okay, from the side to the bottom. Another EN from side to side. Okay, from side to side. So this is going to be, okay, COEN3. Yeah, I do not know whether it's 2 plus or neutral. Yeah, but I just, okay, put it over here. Yeah. So now if I want to actually write down, okay, the optical isomerism for this, okay, if using EN, okay, how do I write down? Okay, quite simple. Okay, just use the mirror image. If EN here, EN, so here to here. Okay, this one from the top to this. Okay, so EN, you put like this. This one, okay, should be EN, put like this. Simple. Okay, quite simple for optical isomerism. Now, what is so difficult then? Yeah, the things are going to be more difficult, okay, if you want to represent them fully. Yeah, if you want to represent them fully, it's going to be a little bit tough. Yeah, a little bit tough. Why? Okay, to save time, I will actually select this. Okay, select this. Okay, I copy, put it here. Okay, and this one, I will select this also, copy, put it here. Now, if I want to represent this in full, okay, how do I represent this in full? Yeah, so I just need to put CH2, CH2, yeah, and then NH2. CH2, CH2, NH2, and then NH2 here. Then this one will come. This one will come. Okay. The same thing. Okay, you do the same thing. Okay, here, let's see whether I can erase this. Okay, you just put erase a bit. You erase a bit. Okay, you do the same thing. Okay, so you put CH2, CH2, then NH2, join. NH2, join. NH2, CH2, CH2, NH2, join. Okay, so you do the same thing over here. Okay, so you just need to change this. I don't want to waste time and draw over here. Okay, maybe, yeah, maybe I'll draw fully for the one that is not so common. Yeah, the one that is not so common is this one, because in the textbook you can always see related to EN. Yeah, but this one is less common, so I will draw for you this. Okay, the full version. Okay, so let's say we start from the beginning. Yeah, let's say you really do not know, or you didn't follow what I say just now. It's okay. We start from the beginning. Okay, let's say we are talking about COOX3. Okay, this is going to be what I'm going to draw. So you just need to put CO over there. Okay, you put the dotted line. Dotted line here, dotted line here. This one coming out. This one coming out. Okay, you will actually use the same thing over here, so I'll just copy and paste it over here for later. Okay, now the first thing you do, this one go up, go down. Yeah, so OX. Okay, OX is what? Okay, OX is going to be C double bond O, O minus, C double bond O, O minus. Yeah, so I want to actually put that in. So O minus bonded to C double bond O, C double bond O, O minus, top connect to the side. Top connected to the side. Okay. Then do the same thing. C double bond O, C double bond O, O minus, O minus. Okay, let's say here also you want to write first C double bond O, C double bond O, O minus, okay, O minus. So from here to here, from here to here, from here to here, side by side, yeah, from here to here. Okay, so if you want to draw the optical isomerism, yeah, you just need to follow, yeah. So if this one is going to be here and then it's towards here, so you just draw double bond O, double bond O, O minus, O minus, you just bring. Okay, actually even the O minus no need to mention because it will be counted together, yeah. So I'll just erase the O minus first, okay. So it will be counted together as an overall charge. Okay, so this one I put over here, assuming, okay, this is cobalt 2 plus, okay, cobalt 2 plus. So 2 plus OX is going to be 2 minus, so 3, so minus 6. This is going to be 2 plus negative 6 is going to be negative 4. So assuming this is negative 4, yeah, the charge is 4 minus. Okay, assuming it's 4 minus. So if it is 4 minus, make sure you put a bracket. Don't forget, yeah, put 4 minus. Okay, you must put. Okay, now a bit messy, I'll just clean up. Okay, let's continue. So here, okay, it's going to be, we just need to follow, yeah. So this one is side by side, so it means must be side by side. C double bond O, double bond O, O minus, no need to show because it's already going to be shown together. Okay, 4 minus here. So this one you just put over here, coming over here side by side. Okay, and then, okay, this part, okay, is going to be C double bond O, C double bond O, O, O. So they will go here. Okay, so this is how you draw. Yeah, this is how you draw related to this optical isomerism. Yeah, I hope you can understand this completely. Okay, so the next step, okay, is just